In this video I'll show you how I use electroplating to apply a thick layer of copper, silver or gold to 3D printed jewelry. This process gives the 3D prints metallic properties, making them indistinguishable from real jewelry on the outside. Whether resin or FDM, copper or graphite, conductive paint, hand polishing or simple tumbler polishing, I'll show you how it's done and what you need in this detailed video. Yeah, let's get started. I'm aware that this is a controversial topic. Many will argue that it's essentially just plastic or that you could just cast the pieces using the lost wax technique. My approach here is to try something new and combine modern technology with the ancient technique of electroplating. I deliberately choose both FDM and resin prints because essentially it works perfectly fine with both. Resin is quite suitable for jewelry if you want extremely fine details in your 3D prints. Once you've been doing this for a while, you develop a pretty good workflow for it. For everything shown in this video, I use protective gear. It's important for me to emphasize this every time. No hobby is worth ruining your health. So put on a respirator, goggles and gloves. Stay safe. Elego sent me their new wash-cure combo, which I'm using to cure the resin prints. The setup with the mirrors is pretty clever since I don't have to keep flipping the prints around. So I've ended up with quite a lot of prints here. And yes, they are all printed at the highest possible resolution with anti-aliasing and image blur, but you still can't avoid post-processing the parts. I bought myself a small handheld sander, which allows me to work on FDM and resin 3D prints quite effectively. However, it still takes a long time. Once you're confident after hours of sanding that the pieces can't get any smoother or more even, it's time to make them conductive. This is a prerequisite and we have several options for achieving it. If you can get your hands on it, conductive copper paint is a great choice. It can be thinned and applied with an airbrush. The second option is DIY graphite paint, which is also airbrushable when thinned. Lastly, there's the ready-to-use graphite copper spray. All three methods work fantastically when used correctly, each with its own pros and cons. Before I explain how I make my own graphite paint, let's first test the graphite spray. Just spray it on and let it dry. A common mistake when using these graphite sprays and paints is forgetting to polish them. Sure, they look beautifully black, but the conductivity is too low. Polishing can significantly improve this. I use a microfiber cloth for the job. A quick test? Yes, it works very well. Now, onto the remaining pieces. In the end, I coated all the jewelry prints, once with copper conductive paint and once with graphite. I wanted to see if I could notice any difference at the end. Okay, my recipe for DIY graphite paint is as follows. Take 3 parts graphite powder, 20 parts acetone and 1 part superglue. Mix, airbrush, polish, measure, 600 ohms. Yay! So, this is a commercial acidic copper electrolyte which I use to copper plate my conductive prints. Attentive viewers recommended aerating the electroplating bath well to increase the deposition rate. So I built a stirring station. A stirrer keeps the solution moving and improves the deposition rate. Whoops, way too fast. The cool thing about graphite paint is that unlike copper conductive paint, it's quite durable. Now I can attach copper wires to the objects and secure them to my rotary jig. The jig ensures an even coating because I'm using only one anode here. I typically use 5 amps laboratory power supply that can deliver constant current. I connect the positive terminal of the power supply to the anode, which hangs in the bath. The anode regenerates the bath and dissolves over time, so I catch the residues with a coffee filter. I've been using this bath for years and regular maintenance really pays off. I connect my rotary jig to the negative terminal and immerse it in the electrolyte. Then I set the power supply to constant current mode and code at 1 amps per square decimeters for 4 hours. A shiny copper layer forms relatively quickly. You can check it occasionally, and if everything looks good, you continue. Afterward, I rinse it with distilled water. I repeat this process for all the remaining pieces. Larger prints works very well too. In the end, you get shiny 3D prints coated with 0.2 millimeters of copper. That's relatively thick. There's no noticeable difference between the graphite and copper conductive paint. If we take a closer look, we'll notice that while these pieces are shiny, they still need to be polished to achieve a mirror effect. This involves deburring, sanding, pre-polishing and high gloss finishing. I thought the best way to try this would be with my rotary tumbler. For this, I got a variety of grinding and polishing media. For deburring and sanding, I have 3 different ceramic grinding stones, fine and coarse abrasives, plastic grinding media, pre-polishing stainless steel satellites and walnut shell granules for the final polish. And this is what I did. I take a container and clean it thoroughly with water. It should be completely residue free. This is a 3-pound barrel. Next I add 4x4mm pyramid and cube ceramic media, coarse grade. Cover it with water, then add a bit of coarse grinding compound. After that, place the copper jewelry inside. I'm curious about what the optimal time might be, but I ran mine for 10 hours. Ah, great! All the shine is gone. Don't worry, we'll bring it back. This time, I'm using fine ceramic media in the same size along with coarse polishing compound. Then, another 7 hours. It feels like it's getting worse and worse. Now plastic polishing tetrahedrons with fine polishing compound. You know the drill, always clean the container thoroughly. 6 hours. Finally, time for pre-polishing. For this, I use stainless steel satellites with a drop of dish soap and water. 6 hours. Basically a very good idea to polish copper-plated parts with the tumbler, because it's very efficient. It can be very efficient. I took a closer look at 2 earrings. There are 2 spots that showed some wear, and I don't want to keep that from you. I've adjusted the tumbler times in this video, so the pieces are quite durable, but there's always a limit. Now it's time for the final step. Dry polishing to a high gloss with impregnated walnut shell polishing media. 20 hours. Yes, you heard that right. Yeah, these pieces came out pretty well. Now, they just need to be cleaned thoroughly and then you'd be done. But first, a note on disposal. As a general rule, collect all electrolyte waste and take it to a recycling center. That's the only place where this waste belongs. Please be responsible. So, we want gold, palladium or silver jewelry. It's possible to add additional layers of different metals which are usually thinner. The order of these layers is also important. For these pieces I applied a nickel barrier layer to prevent diffusion with the gold and silver. However, nickel electrolyte is toxic and not a good choice for jewelry because it's also allergenic. A much better alternative is palladium. I ran out of it, and since I'm using these pieces for demonstration purposes only, I didn't use palladium. If in doubt, you can also apply gold and silver directly onto the copper. And that's what I show you now. This is a gold electrolyte bath. It works just like the other baths using a suitable anode. Here stainless steel, but graphite also works. And the appropriate current. I'm using constant voltage here and doing it by feel. The gold deposits quickly, and the longer the object stays in the bath, the thicker the layer becomes. Never let the electrolyte come in contact with any acid. Here are a few examples. I also made cufflinks with the YouTube names of my new channel members. Thank you so much for supporting me. Guess what? There are various silver electrolytes as well. It works fantastically but can be a bit tricky. The silver electrolyte requires a silver anode. This one here is made of pure silver. At first the electroplated items turn a bluish color, but after rinsing they take on their characteristic silver tone. So nice. Now I have a whole bunch of jewelry here and I'm not sure what to do with it. If you have any ideas, please let me know. Overall, as a conclusion, I think it's pretty cool. At least for rapid prototyping, this method is really well suited. It feels good, it's super lightweight and the coating is thick enough that it won't rub off. It also seems to be quite durable. Anyway, I'd really appreciate it if you could like, share and especially comment on this video. It helps my channel immensely and I'd be forever grateful. Take care and see you next time. Tschüss!